Okay, students, so we're picking up right where we left off from yesterday. Yesterday, we're talking about qualifications for triangles to be similar. We had the angle postulate, the side angle side theorem. And now we got the side junk, all right? And remember, when we were talking about triangles, if all three sides had a corresponding congruent side, then the triangles were forced to be congruent. And remember, we even played those fun games, triangle to bag and all that stuff. So if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Similarly, pun intended, smiley face, there's also a side similarity theorem. All right? If three sides of one triangle are proportional. All right? When you see triangles and you're talking about sides, you immediately have to know proportional. If three sides of one triangle are proportional to the three sides of another triangle, then the triangles are similar. So we got some problems we're just gonna run through. All right, is triangle ABC similar to triangle XYZ? Well, the ratio of AB to XY is 4/5. BC, 6. YZ, 7.5, 6/7.5, which is 0.8, and this 4/5 is 0.8. Since we have this goofy fraction, it might be easier to translate it to a decimal. And then we have AC over XZ, 8/10, which is again 0.8. So notice how all side lengths are proportional. We have a scale factor of 0.8. So are they similar? The answer is yes. Same thing down here. Are the triangles similar? Well, we have 4/6, which goes to 2/3. We have 6/9, which goes to 2/3. And we got 7/10.5. This one's a little goofy. Just believe me, this one also goes to 2/3. So again, corresponding sides, they're proportional. They all have the same fraction. So are they similar? Yes. Cool. All right, now these problems I stole from the iBook. Let's just go ahead and start them, I guess. All right, in this problem right here, those are the corresponding sides. These triangles are being rotated. And then these are the corresponding sides. So I'm just going to say, well, I'm going to write a fraction just using this lower one. I'm going to say 6/3x plus 1. Well, which side corresponded to 6? That was 3, so that's going to have to be on top. And then 5 in the denominator. Now, before I cross multiply, since I have a bunch of junk, I'm going to put parentheses around that bunch of junk. Why do I like to do that? I'm going to have 6 times 5, and then 3 parentheses 3x plus 1. So I like to do it so I remember I got to distribute. That's why I like to do it. Subtract 3 from both sides. 27 equals 9x. Divide both sides by 9, and x is going to equal trace. Nice. All right. Cruising right along. This problem is absolutely bizarre. All right. These triangles are actually being reflected over some kind of line. They're being reflected. So 9 corresponds to there. That and that. Alright, this problem's a little goofy, but we'll fight through it. Alright, so let's solve for x first, because why not? Gotta solve for something first. So I'm going to say 18/9. I'm going to do this side over that side. And since 18 was on top, 5x minus 2 must be on top over 21. Alright, so again, setting up this proportion in blue. If I can set this up, I'm in incredibly good shape. Again, I like to put parentheses around that junk, cross multiply. I'm going to get 18 times 21 equals 9 parentheses 5x minus 2. All right, what's 18 times 21? Some enormous number, 378. Then distribute over here. I'm going to get 45x minus 18. All right, add 18 to both sides. Divide by 45. X equals 26.4. All right, nice. Similar thing for Y. Let's just keep that 18 over 9. I like that. And then that's going to be 12 over 3y plus 3. All right, goofy problem. We got some decimals. I wonder if we're going to get a decimal this time. My prediction is no. I think actually y is going to be some nice slick number that you guys all adore. All right, same kind of thought process. Distribute 18 times 3 is 54y plus 54. This is a little sloppy. That says 9 times 12. 9 times 12 is 108. And you subtract 54 from both sides, you're going to get 54y equals 54, or y equals a very famous number, 1. Okay? And then last problem of the video. All right. Now, we're going to do a cheat code on this one. We're going to do a cheat code. We're going to say, well, let me think about how I want to say this. We got this little side, and then we got this larger side. So I'm just going to say, well, that's 2, and that compares to 10. I'm going to compare 2 to 10. Well, over here, I got this little side, x, and it compares to the larger segment, x, or 15. So I'm going to compare x to 15. All right, this ratio, this scale factor is going to be the same. All right, you can set it up like this. You're going to get 30 equals 10x divided by 10. 3 equals x. Okay, so that was part 1 of the video. iBook problems, there's a part 2. This is still going to be worth points. This is going to be worth 2 points, maybe 3 points. 2 points or 3 points. I haven't decided yet of the whole notes. Alright, so don't skip the iBook part. Make sure you watch the video, and we're going to be writing all this stuff down on this page right here. So stay tuned, do the next video. Make sure you submit them, so on and so forth. Ready, go.